Hello and welcome to lesson 4.6. We are on finding and using unit rates. And so a couple of big things I want you to remember here and about unit rates. Number one, a rate is a ratio that has different units of measurement, top and bottom, for the two terms. Next thing, a unit rate, unit means one. All right, so unit means for one. So write that down if you can, please. And typically we have the unit, the one, on the bottom of the ratio. So if we're setting it up like a fraction, remember I said earlier in the lessons, if we're doing money, money's usually on top, and it's usually for one of something. All right, so that's one big idea. Now they're not all like that. It might be miles per gallon, how many miles you can go on 1 gallon of gas. It might be miles per hour, how many miles would you travel in 1 hour is your speed. And dollars per something would be a unit rate cost. And this is a great way to really compare costs. We'll find out. So let's look at our first example. We have a star fruit, or carambola, is the fruit of a tree that is native to Indonesia, India, and Sri Lanka. Slices of the fruit are in the shape of a 5-pointed star. See them over here. And Laura paid $9.60 for 16 ounces of star fruit. Find the price of 1 ounce of star fruit. So since we're finding it for 1 ounce, we are going to be finding a unit rate. Recall that a unit rate makes a comparison to 1 unit. You can find a unit rate by dividing the numerator and denominator by the number in the denominator. So basically top divided by bottom. So even going way back to fractions and decimals, it was top divided by bottom. And that's basically the same thing we're going to end up doing here, because the denominator then on the bottom becomes 1, and that's our unit rate. So write the unit rate for price of star fruit. Write a ratio that compares price to weight, I believe is what they want here. Price to weight. And so we come up here, it was $9.60 for 16 ounces. 16, and OZ is your abbreviation for ounces. Now divide the numerator and denominator by the number in the denominator, I think is what they want me to say. Bottom number, bottom term. So divide by 16, divide by 16. So we're showing it across there, but it really is the same as top divided by bottom. And so if you were to pull out your handy dandy calculator, which I'm doing right now, and pull this up, let's see, I get 9.6 divided by 16 equals 60 cents. All right, so I get 0.6. So that looks funny. If it's money, make sure you put your 100th place on. So 60 cents, you can put a 0 in here too. So 60 cents per ounce. So filling in the bottom here. So the unit rate is, and I'm going to write it 60 cents per ounce. And the price is, I don't know what they're doing different here. Just going to write it with the dollar sign, 60 cents per ounce. So quick review. If you're using a dollar sign and it's just cents, you can put the 0 in the ones place. You don't have to. But you really should make sure you need to have a 100th place, and the dollar sign goes to the left of the decimal. If you're going to show that as 60 cents with a cent sign, then it's a whole number 60 and the little cents sign to the left, right hand side. So those two are equal, but you got to pick one or the other and do it correctly. If you kind of mix things up, it would be incorrect. So let's see. Our example here on page 244, unit rates are a great way to compare two things, because you get apples to apples or oranges to oranges. If you don't have a unit rate, you basically are comparing apples to oranges. So our example, during migration, a hummingbird can fly 210 miles in 7 hours. I'm going to underline that. That was my hummingbird. And the goose can fly 165 miles in 3 hours. Which bird flies at a faster rate? So I need to find out the number of miles each bird flies in 1 hour. That would be my unit rate, and then I can really compare. So write the rate for each bird. So my hummingbird was 210 miles per 7 hours. The goose was 165 in 3 hours. So now find the unit rates. So divide by 7, divide by the denominator. And that I can do in my head. 21 divided by 7 is 3, and I'd have a 0 left over. Pattern is zeros, so 30 miles in 1 hour. And then over here, 165, I need to divide by 3. That one I'm going to quick do on my calculator, and I get 55 miles per hour. Compare the unit rates. So blank miles per hour is faster than blank miles per hour. So 55 miles per hour is faster than 30 miles in an hour. And so that was the goose. So the goose flies at a faster rate. Okay. So same thing as going top divided by bottom. All right. So if you go to the store and you want to compare costs, sometimes bottles of juice might be different amounts of juice, fluid ounces in a bottle. And so you can't really just judge it strictly based on the price. But if you look on the labels at the store on the shelf, they'll always give you a unit rate. And then that's really the best way to compare. So let's look at an example like that. So if I have a 64-ounce bottle of apple juice, it costs $5.76. A 15-ounce bottle of apple juice, so 15 ounces, costs $1.80. Which item costs less per ounce? So now remember, I want dollars on top, and I want my unit rate on the bottom here. All right, so write the rates. So it was $5.76 for 64 ounces. And over here, I had my $1.80 for 15 ounces. So 5.76. So I'm going to divide both by 64. So I'm going to take my $5.76 and divide that by 64 equals, and I get 0.09. So 9 cents per ounce, per 1 ounce. Per means for one usually. $1.80. I'm going to divide by 15. So again, use my calculator, 1.8 divided by 15, and I get 12 cents, 0.12 for 1 ounce. Now compare. So blank per ounce, 9 cents. 9 cents per ounce is less expensive than 12 cents per ounce. So my 64-ounce bottle costs less. Best way to make a comparison. Okay. Let's do one more example down here. Let's see if I can zoom this in just a little bit that I can still get it all in for you. Okay. This is bottom 244. At one grocery store, a dozen eggs costs $1.20. At another store, 1.5 dozen eggs costs $2.16. Which is the better buy? So you have options here. You can either deal with this as in dozens, or you can deal with this as per egg. Either would be fine. So let's go with store one was $1.20 for 1 dozen. So I'm going to use that as my unit rate because it's one dozen. Over here, and I don't have to divide anything because it's already given to me as 1. Now over here, I have $2.16 for 1.5, so for 1.5 dozen. So I need to divide top and bottom by 1.5 to get it down to 1 dozen. So 2.16 divided by 1.5 equals This would be $1.44. Let me slide this over. Sorry, get my hands out of the way. So $1.44 for 1 dozen eggs. So what was cheaper? Actually, my $1.20 for 1 dozen was cheaper than buying 1.5 dozens. And that's usually unusual. Usually the more you buy of something, the lower the unit rate is, but not always the case. So the unit price is lower at store 1. So a dozen eggs for $1.20 is the better buy. Now, I just want to quick show you checking that out with per egg. Let's see how much. It should still work out the same way. We should have cheaper over here. But $1.20, oops, sorry. Let's start over again here. 120. Now a dozen is 12 eggs. Okay. And over here, 1.5 dozens, I had 216. 1.5 dozen is 18 eggs. So let's find out what our price is per egg. So 1.2 divided by 12, that's going to be, 10 cents. So I get 10 cents per egg for 1 egg, 1. And 2.16 divided by 18 equals 12 cents. 12 cents per egg. And now when I say per egg, we don't have to really show the 1, but it does mean 1. It is a unit rate. When you just say like per egg, it's assumed you mean the 1 if you don't say another number. So again, it was still cheaper, and it should be that way, no matter which way you do it. All right, let's look at 1 or 2 examples over here on page 245. And just a word of warning that you really have to stop and think about the situation they're giving you, the question they're asking you. When you're evaluating unit rates, do you want the lower one or the higher one? It depends what they're asking for. If they want to know the cheaper and dollars on top, then you want the lower number. But if you're looking for speed and you want to know who's faster, you want the bigger number. So you really have to evaluate every situation in a word problem to see what they want. So our directions, write the rate as a fraction. So that's the original rate they give you, and then find the unit rate. So Sarah drove 72 miles on 4 gallons of gas. So right here is the first part, write the rate as a fraction. But I didn't put my label in there, and I need that. When it's a rate, you need the labels top and bottom. Now find a unit rate. So I would have my 72 divide by the number on the bottom so that you get 1. And 72 divided by 4 equals 18. So she drove 18 miles per gallon. That's how she got 18 miles per gallon. All right. Let's look at number 3 here. Amy and Mai have to read Bud Not Buddy for class. Amy reads 20 pages in 2 days. Mai reads 35 pages in 3 days. Who reads at a faster rate? Again, really important to keep your work neat and label who's who. So Amy was 20 pages in 2 days. And I would divide by 2 to get 10 pages per day. 20 divided by 2 is 10, makes sense. And again, this is 1. And then Mai read 35 pages in 3 days. And you can see that that's going to be more than 10, right? Because 30 divided by 3 would give me 10, but it's 35. So I can see right there that that's going to be the higher number. So 11 point, and it's repeating 6, but that's fine. I'm just going to put 6, 7, round it off. And that is pages per day. So who read at a faster rate, the higher number. So more pages in 1 day, the answer was Mai. Mai read at a faster rate. This one is the faster. Okay. And our last example for this lesson at the very bottom, page 245, tell which rate is faster by comparing unit rates. All right. Again, be careful. Faster could be a higher number. Faster could be a lower number depending on what's on top and what's on the bottom. So you got to stop and think about it. miles per hour. So here's 160. I'm going to divide by 2. Divide by 2 is going to, this side is going to be 80 miles per 1 hour. And over here I would divide by 3, and I get 70 miles per 1 hour, which is faster, the higher number. So I'd rather go 80 miles in an hour, that's traveling faster, than going 70. So my original 160 miles for 2 hours. Over here, let's do feet per minute. Divide by 9, divide by 9. 27 divided by 9 is 3. I'd have my 0 left over. So 30 feet in 1 minute. Divide by 9 to get my unit rate, and I would get 20 feet in 1 minute. So the farther that I can go, just like over here, the farther I can go in an amount of time, unit rate is going to be faster. So that one's faster. And then same thing's going on over here. It's meter per second, so it's still distance over time. So you still want the higher number, nothing new there. All right, that's it for lesson 6. See you in a bit.